Hey guys, today we're going to be reviewing polynomial arithmetic, which includes adding, subtracting, and multiplying polynomials. So first we'll start with addition, which is pretty simple, even though there's a set of parentheses here. Anytime we have two polynomials being added together, all we're doing really is combining like terms. So we're looking for the same variable combination with the same powers and combining their coefficients together through addition. For example, here we have x to the fourth, and we're going to combine that with the x to the fourth from the second parentheses. So minus 1 plus 7 gives me 6x to the fourth. Next, we're going to do the x to the fifths. So we're going to combine x to the fifth with this x to the fifth. 13 plus 15 gives me 18x to the fifth. And finally, we're going to do x to the third and x to the third. A plus 6 and a minus 6 actually cancel each other out. Okay, so since they cancel each other out, we don't even have to write an x to the third term here. We can just drop it. The second thing we want to remember about adding, subtracting, and even multiplying polynomials is that we want to write them in standard form. Okay, standard form is when we have the exponents of our variables in order from biggest to smallest. Okay, so 6x to the fourth plus 18x to the fifth is not in standard form because 4 is less than 5. So we're going to rewrite this. The final answer for this would be 18x to the fifth plus 6x to the fourth. And that would be the final answer that we would input into Delta Math. Now, the only difference between adding and subtracting is this negative sign right here in the middle. The negative sign, we're going to treat it as if it were a coefficient of a -1, meaning we're going to take that negative and distribute it to everything in the parentheses it is directly next to. So this positive 2x to the third becomes a negative 2x to the third. This positive 8 becomes a negative 8, and this negative 4 becomes a positive 4x to the fifth. Once we have distributed that, we're just going to bring down the terms from the first parentheses that were not affected by this negative. And once we've done that, we go back to combining our like terms. So 7 is a constant, and negative 8 is the other constant. So when we combine those together, we get a -1. Next, we have negative 13x to the third. We would combine that with anything else with the x to the third. So minus 13 minus 2 gives me minus 15x to the third. Next, we have an x term, but there is no x term in the other parentheses, so we can actually just bring that down as is. And lastly, we have an x to the fifth term, which also does not have anything else to combine to, so we bring that down. Once we have all of our like terms, we are going to, again, order our exponents from highest to lowest to put it into standard form. So the highest exponent we have here is x to the fifth, so it becomes 4x to the fifth. Then the x to the third term, again, we bring the negative with us. Now there is no x to the fourth term, so we skipped it. There is no x to the second term, we skipped it. And we're allowed to do that. Okay, as long as the exponents do go in order. So this should be the final answer here after performing this subtraction. Now, the only thing else we need to remember about addition and subtraction are the key words that indicate we are adding or subtracting. For instance, the word sum, hopefully we understand, is adding. So we are adding 3x squared minus 7y squared plus 9 and 2x squared plus 2y squared minus 16. Now, another way to do this is actually to use what I call the vertical method, which means we stack like terms together so we know which ones to add. So what I'm going to do is I'm going to write the like terms from the second parentheses here, right? And since there's no change of signs, we can just add columns going down. So 9 minus 6 gives me a plus 3. Minus 7 plus 2 gives me a minus 5y squared. And 3x squared and 2x squared also gives me a 5x squared, making my final answer 5x squared minus yx squared plus 3. Also with subtracting, we're going to subtract this first parentheses from the second parentheses. Please remember that this from is a key word that tells me almost like I'm switching the order, right? I'm going to take away this first parentheses from the second parentheses. So if I was going to write this in a line, I would rewrite this as 2x to the third minus 5x squared minus 2x plus 7, and subtract from it minus x cubed plus 4x squared minus x plus 6. I'm going to distribute my negatives to all four, so that becomes a positive x to the third power minus x squared plus x minus 6, and combine my like terms. So x cubed will combine with this x cubed to give me 3x cubed. Minus 5x squared combines with minus 4x squared, which would give me a minus 9x squared. Next becomes minus 2x plus x gives me a minus x. And last but not least, 7 and minus 6 gives me positive 1. That is in standard form already, 3, 2, 1 as our exponents, so we are done. Okay. Now time for multiplying. Hopefully remember that when we have something outside of a parentheses, we can distribute that entire value through the parentheses using multiplication. So when I multiply 8r squared times 4r squared, we have to remember our exponent rules of r squared times r squared becomes r to the fourth because I'm adding my exponent, the coefficient being 32. Now 8r squared times minus 5r, so we have a minus sign. We have 40 from 8 times 5, and we get r to the third power. And the last one, 7 times 8 becomes 56. No r's to combine. So we get, 56r squared. Now we check, is it in standard form? It is. So we are done. Remember, that's called the distributive property, and it can be done with any combination as long as this is just a monomial. But of course, not everything will be a monomial. We also have binomials, trinomials, etc. So when we have a binomial, which is a two-termed expression times another two-termed expression, we have two options. We have FOIL and we have box method. Both are accurate, both are valid, and I am going to review both of them right now. So with the FOIL method, remember that stands for first, outer, inner, last. First, outer, inner, last. Meaning first I'm going to multiply the first terms to get 18x squared. Then I'm going to multiply the outer terms to get plus 15x. Then I'm going to multiply the inner terms to get minus 12x. And then I'm going to multiply the last terms to get minus 10. Last thing we have to do is make sure it's in standard form, meaning there are no uncombined terms and that our exponents are from highest to lowest. So 18x squared stays, but we have to combine these two like terms to get plus 3x and bring the minus 10 with us. Now, we should get the exact same answer if we set up the box. The box method is done by setting up the number of rows and columns to match the number of terms in each expression. So for this one, it's 2 by 2 because they're 2 terms in the first parentheses and 2 terms in the second parentheses. Next, we line the parentheses with the terms from each expression. Okay, and then we multiply box by box, and we look at the top and the right. That's what we're multiplying. So 3x times 6x gives me 18x squared. This minus 2 times 6x gives me minus 12x. This 3x times 5 is 15x, and this minus 2 times 5 is minus 10. Notice the values in the box, right, here, 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 and here, are the same as these 4 values here. So you end up with the same standard form equation of 18x squared, combining these like terms to get 3x minus 10. Okay, so we can apply this box method when we have parentheses with way more terms. Okay, now again, we could use distribute here, but we would have to what we call double distribute the 7x minus 3. Again, It's up to you, but I always prefer the box method because it makes sure I do not forget any terms. Now, in this box method, I have the 2 along the side for the binomial, but I have 3 along the top for the trinomial. So I write my terms for each box, and then again, multiply box by box. So 2x squared times 7x gives me 14x cubed. Minus x and 7x gives me minus 7x squared. 4 times 7 is 28x. 2x squared times minus 3 is minus 6x squared. Minus x and minus 3 is a positive 3x. And then last but not least, a minus 12. All that's left is for me to combine like terms. Now, I tend to do it directly from the box itself. So I look for like terms. X squared and x squared get combined, and 3x and 28x get combined. So 4x to the third power minus 7 minus 6 gives me a minus 13x squared. Then we have a 28 plus a 3 is plus 31x minus 12, and that is our